So today is a big one. It's about limiting reagents and excess quantities. And so we need to talk first about what a limiting reagent is. First off, just a reminder that stoichiometry is all about mole ratios. So when you have an equation like this, 2 sodiums and a chlorine making 2 sodium chlorides, we already know that the mole ratio is found by the coefficients in front of the each formula in the equation. So through that, you should already have figured out that 2 moles of sodium should react with 1 mole of chlorine. But in real life, is that always the case? Does every person always put 2 moles of sodium and 1 mole of chlorine? Well, no. But are the sodium and chlorine always even in that ratio? The answer is no. So we won't always have those perfect amounts, and even if they're not that perfect amount, in real life it won't be in that ratio. So, like, imagine, for instance, that we take that same equation and instead I gave you 3 moles of chlorine and 2 of sodium, and then I asked you, hey, which would we run out of first? So you look and you're like, okay, well, 3 moles of chlorine. You're only using 1 mole of chlorine for every 2 moles of sodium, so 3 moles of chlorine is actually a lot, and then 2 moles of sodium isn't a lot. So we would definitely run out of sodium first there, because you need 2 moles of it for every 1 mole of chlorine. So if you had 3 of that and only 2 of that, you would use up both these moles and only 1 mole of chlorine, and you'd have 2 left over. So that's kind of what limiting reagent is. So we know we would run out of sodium first, and therefore we call sodium, in this case, the limiting reagent. And so the limiting reagent, which is the same word as reactant, by the way. So when you see reactant and reagent, they mean exactly the same thing. Why are there 2 words for it? I don't know. But the limiting reagent or reactant is the one you're going to run out of first. Okay? So far so easy, and I can even back it up with a further analogy. And so if we're going to make some sandwiches, and we want to make some grilled cheese sandwiches here, you can see that they're quite delicious. We want to make sure that we have both bread and cheese, and so in this case these are reactants, the bread and the cheese. So in order to make a grilled cheese sandwich, everybody knows that the ratio is 2 pieces of bread to every 1 piece of cheese. And so if I gave you an example saying, oh, you have 36 pieces of bread and you have, I don't know, 15 pieces of cheese, which would you run out of first? And so because of the 2-to-1 ratio, you could probably figure out that the cheese is the one that you're going to run out of. But let's say I give you a more difficult way to figure out what you're going to run out of first. Like, let's say you're running the grilled cheese sandwich day for, all of Kamloops, in which case I said you had 36 tons of bread, okay, and that you had 21 tons of cheese. Now what are you going to run out of first? Well, that's a more difficult question, because this unit that I'm giving you is not just the numbers, it's how much it weighs. So we're going to require a little bit of math. Okay? So we're going to make some sandwiches. Figuring out what the limiting reagent is only the first part. The rest of it is figuring out how much extra you're going to have left over. So in an example here, we're going to do both. I'm going to figure out, hey, what's the limiting reactant or reagent, and how much is left over. So here is the example. Notice that I'm giving you a certain mass, just like of bread, except it's FeCl2, and another certain mass, except instead of cheese it's KNO3. And I'm also giving you an unlimited amount of HCl, because the question becomes a little bit harder when I give you 3 ingredients and try to get you to figure out which you're going to run out of first. So let's just start with 2. So here's our bread, if you will, and here's our cheese, if you will, and we are going to figure out, according to the equation, the answer to 2 questions. First off, here's the chemical equation. Okay, notice that there are 3 reactants and 4 products, And in this chemical equation, I want to know two things. Number one, which chemical is the limiting reactant? Okay. And number two, how many grams of that reactant, it says each, but how many grams of the other reactant are left over? Okay, so we're going to focus in on iron chloride and KNO3 and say, okay, we have as much HCl as we want. And so let's take a look at how we would do that. We're going to solve this question in two steps. The first one is going to be comparing the two reactants by stoichiometry. So in the reactants we have 3. This is unlimited, so we are going to completely ignore this because we're not going to run out and we are going to have as much as we want. And that's the typical question that you've come across before stoichiometry, is saying, oh, you have this plus this and it becomes that, and they didn't tell you how much of everything. And now how much of everything is important. So because we have unlimited that, we're going to cross that out. So in this question we have a certain amount of this and a certain amount of this. Now how do we figure out which one is in excess? Well, what we could do is figure out, well, you know, how much product would this one make? And how much product would this one make? And we could compare them. But there's actually an easier way to do that. What we're going to do is we're going to compare these directly. Okay, so we are going to look at iron chloride here and KNO3 over here and compare them directly. So once we're done comparing them, what we're going to do is, and I'll show you how that's done, we're going to, after that, figure out how much is left over by subtracting it. Okay, so 2 steps. Compare the two reactants, then figure out how much is left over. Okay, so remember that it doesn't tell us how many moles of iron chloride, it says grams, and it doesn't tell us how many moles of KNO3, it tells us grams. And so that makes it a little bit tricky, but only a little bit. So what we're going to do first is, again, compare the two reactants by stoichiometry. So we have our equation here again, we need it for the mole ratios. As a reminder, there are 56.8 grams of this. Okay, and then there are 14 grams of this. And so those are our two values. Notice that it's giving us 2 starting values. And so you might have, a little bit of confusion here because there's 2 starting numbers. But in this question, you actually get to choose which you want to start with. And the other one is going to be left over for comparison. So in this example, because 56.8 grams is first, I'm going to use that as my starting amount. So let's go through this, okay, individually, so that it doesn't look so confusing. How many moles of KNO3 are there? Or sorry, grams? We are going to start with the starting value of 56.8 grams of iron chloride. Okay, we're going to, again, this is just using the mole map that we've been using for the last few days. We are going to convert that into grams of FeCl2, or sorry, convert it into moles from grams. And now we cross the mole bridge with the mole ratio. So where did I get those numbers again? From right, here. So 3 moles of iron chloride to 1 mole of KNO3. And then the next part we transfer it into grams of KNO3 by using the molar mass of KNO3. And we find our answer. Okay. What this answer means is this is how many grams of KNO3 that would react with, we start with 56.5 or something, grams of iron chloride. Okay, so what this represents is saying that if you had this amount, if you had this amount of iron chloride, that you would need 15.2 grams of KNO3. But you can see that we don't have 15.2 grams of KNO3. We have 14 grams of KNO3. And so obviously then, because 15.2 is greater than 14, okay, then we know that KNO3 is the limiting reagent because there's not enough of it. Based on the amount of iron chloride we had, we need this much KNO3 in this reaction, but we don't have it. We have less than that. So in step 1 of this question, we have figured out that KNO3 is the limiting reactant. Okay, now the thing about excess quantities and about actually every question in chemistry is you need to always go off of what you have less of, right? So if you're talking about how many sandwiches you're able to make, then you need to talk about how many or what are you limited by. So if you show up to the grilled cheese sandwich factory and you have a whole bunch of bread but only 5 slices of cheese, you're limited by your cheese, right? So the limiting reactant is a very important concept in chemistry. So for our last page, we need to figure out the second part of the question, which said figure out how much is left over. And what we're going to do here is subtract the difference. So we're going to take our numbers from the previous question, and that is the 15.2 grams. Okay, so this was how much KNO3 was required, and this is actually how much is there. And so then what we get is 1.2 grams of KNO3 that are missing. So according to our question, this many grams of KNO3 is extra, but it doesn't exist, but we would need 1.2 extra grams of KNO3. You see that? So this is sort of extra, far above and beyond what would actually happen. And so in order to figure out the moles, the problem is that it's asking how much would you have left over. Would we have this left over? Well, no, because it's the limiting reactant. So because it's limiting, this won't be left over. We know the KNO3 would have run out. So this 1.2 grams is an imaginary number saying that if we just had 1.2 grams of KNO3, that would make it perfect. Okay, so this is the extra, that's the number that are missing, and so what we're going to do is go through the exact equation except in reverse using this 102 question, so you can, number. So you can see that this number is used as a starting value, and it's, again, the grams cancel, the moles of KNO3 cancel, the moles of FeCl2 cancel, and we're putting it back into grams of FeCl2. Okay, so I'm just reverse engineering that. And what you end up getting from that is 4.5 grams of FeCl2. So what that means is after this reaction is completed, 4.5 grams of FeCl2 will have not reacted. So that is in excess, and therefore it's because the opposite of the limiting reagent is the excess reagent or reactant. So that is how you A, find the limiting reactant, and B, figure out which is in excess. And there's more than one method of doing that. You can read the book, and other people do it in different ways, but a very effective way of doing it because it only takes 2 equations. So for an assignment, you need to do the excess quantities questions from the book. I don't have the book with me right now, and I don't have my plans with me, so I can't remember what the numbers are. But Miss Sorensen for sure knows them, so make sure to ask, and that's your assignment for the day. And you need to do those in preparation for the lab tomorrow. Okay, have a good week. Bye-bye.